our third speaker for this session from University Center from our side. IRGS Technologist Dr. Nik Muhammad Zarifi bin Hashim. He's from Faculty of Electronic and Computer Technology Engineering, University Technical Malaysia Melaka. And he will talk about the automated classification of tropical fish in Malaysian waters using underwater imaging and artificial intelligence. So he will talk about this site from our local Malaysian sea. All right, for information, Dr. IR, GS, Dr. Nik, he graduated PhD from Nagoya University, Japan, and he's an expert in digital signal processing, machine learning, artificial intelligence, and etc. All right. So he's been awarded with several grants and also the competition award internationally and in national level. All right. Without further ado, let me invite Dr. Nik Zarifi for his presentation and sharing session.
Okay, thank you so much, Dr. Faiz, for the introduction. Assalamualaikum and very good morning to all. So, me, Nik Muhammad Zarifi bin Hashim from Faculty Technology, Kejuruteraan, Electronics dan Computer from our research group CAVP and MLSP. So, today I would like to continue the discussion on the advances in underwater, data processing, communication, and imaging. Yes, as we can see over here, we have digital ocean. So underneath of that, we have underwater speaker for data processing. We have Honorable Dr. Prof. Sabah and Honorable Dr. Prof. Adam and me. So basically, I will be focusing on imaging perspective for discussion on the underwater technology. I think more or less I will be connecting the computer vision and artificial intelligence to this particular discussion. Right. So the title that I used to discuss for today is automated classification of tropical fish in Malaysia water using underwater imaging AI. So basically, the one that we try to talk about is focusedly on the tropical fish in Malaysia underwater. So that will be the really interesting us and honorable guests from Germany in order to sing and collaborate with future collaboration research, I guess. Again, let me introduce my contents for today. So basically, I will be, I did introduce the webinar in overall. So first of all, I would like to talk about the motivation behind the scene of automated classification for underwater technology and what we did so far, architecturally and system, obviously by imaging, it's not by sonar data and so on and so on. And we try to share how we will do it, the data collection and processing. So the fifth one, we will talk about classification and followed by what is the model that we use, deployment, environmental, and so far what is the achievement of our lab through the underwater perspective topics. So at the end of the day, application and perspective for the future. And finally, I will be concluding everything. Okay. So first of all, I would like to make clear about what is the things that will be covered for today. So basically, automated classification of tropical fish in Malaysia waters using underwater imaging and AI. So basically, that will be the topic. But eventually, I'll be talking about from the back to the top. So meaning AI and water back to the tropical and lastly for the classification. So I think every one of us as engineer, as computer science and whatnot have familiar with this IR 1.0, 2.0, 3.0 and 4.0 recently that happening and explode everywhere in the world. So basically, especially in Malaysia, if I correct, forgive me. So this is my personal observation that happened in demand in Malaysia sites of the technology demand. So early in 1990s, we we often see the engineering. People tend to go to the taking the undergraduate engineering and so whatnot. So from 2000 to 2010, so IT is coming down. So website, www, whatnot. And then back to then, we heard about Froyo and Android and iOS, Nokia Symbian and whatnot, telecommunication. So then now we are sitting and we are standing and we are living with AI. So then what's next? So that will be I leave to you guys to think, and yeah, we will predict and what we will do. I think not far from here. I think less than 5 years. So that will be the direction nowadays. So speaking of AI, artificial intelligence, I think every one of us know about this connection between human on the left and the robots on the right. So basically, a big roof under the AI, we have things that are related to machine learning, deep learning, big data, whatnot, data science and data analytics. So the important things here is basically to say that AI is not belonging to one particular field. So AI belongs to every one of us. Okay, right. So under roof of AI, so we have many things. But the things that we are doing in our faculty is vision. So that what we are doing right now, everything related to the camera, JPEG, imaging, sonar on the way. And then we try to communicate and we try to give the best as we could as research group to vision, focusing on AI. Yeah. So this is the idea that what we have been doing right now. So this is my the one that we did in our PhD time. So this one is currently we are doing. So this one also we are doing right now. So this is the voice. We happen to change to the spectrogram, and we have image profile sound. So what we say. So this is I love you in PM, Malay, aku cinta padamu. So that's the way that things that produced from our throat. It's not meant to be aku cinta padamu, but the thing is the wavelength can be seen clearly there. So this is the X-ray and whatnot. So basically, everything for the images we consider as a data for us. So the data that we have in hand, we can do many things. So that's the things related to AI. So, but the thing is, today I would like only to focus on the computer vision, the one that I working under the roof of CV. So under CV itself, we have several tasks. So we have classification, detection, segmentation, whatnot. Prof mentioned about segmentation. I'm really interested on that. And then the communication things. So basically, for this, we have one of those, we call it classification, the one that we separate the class that we put an image of data in search directory. In Linux, we call it folder in Windows. So we have cat and dogs and fish, for example. So net here, basically, we have many choices. As I mentioned by the first speaker, CNN as the pillar or the father of network so far. We have models, mobile net, LXNet, and Google Net. So basically, bringing the idea of AI, computer vision, and back to classification. So now the problem is this: we try to bring these particular things to the undersea technology. So that's the one that we try to do from 2019, if I may share to you. So basically, we have collaboration in tropical fish farm near to southern states of Peninsula. We have Johor. So later on, I'll share to you at the time that I visited the fish farm. Okay. Right, this is the things that we have in our rivers and in our seas. So we have this, I think, bowl. This is stuffed catfish. This is bowl. In Southern Asia, I think this particular fish is very famous. And the food for the, how to say, masak lemak, that is in English. Yellow curry bowl fish is very nice to test them. In case you have. So we have masak lemak, bau kuning, kind of thing. So this is, we have tilapia or siakap. So this is the other tip of our Terengganu Island kind of samples images. So right. So to introduce this, basically, in Malaysia, we have a complete and various and rich of the marine fishes. So obviously we have this. I think without any mention, catfish is very general for every person. As in Malaysia, we have sela, we have siakap, and we have tilapia and so on. So basically, in order to the idea of the starting point of this particular research is trying to give as much as we could AI to the veterinary and underwater technology for Malaysian perspective.
Yeah.
Right. So this idea is basically happen to face several challenges. So we have labor intensive. Obviously, we need to hire the sea people to go to the sea and things because we don't have UAV yet. underwater fish observation. So that would be a future kind of things we have. Obviously, time consuming because we need to have a good translation to go there. And plus, the final one is error prone. So basically, say that me, Zarifi, wanted to classify one fish and Dr. Faiz is classify one fish. Maybe that particular fish from his and my eye is different. For example, starfish and bowl is similar physically, but only many people can describe it as like you have less policy things. So that would be special thing about our culture. So that's the starting point 2019, if I'm not mistaken. I went to Segamat for starting out this particular research. So then we'll talk about many in academic. So in this particular speech talk, I will try to balance down to the domain engineers, data scientists, and how to say the all perspective of listener. So this is conclusion from that particular paper. So I think AI fish production can be managed more efficiently and sustainably, providing the consistent and safe supply. So this sparked us to accelerate our speed. So basically, based on this particular data, we have clearly, we can see here aquaculture and fisheries is basically the high demand of AI-enabled things. So this is the global ideas. It's not for the Malaysian. So that's the thing happened. So in order to beat it, basically, we need to have three things. The system created by the AI expert must be efficient, scalable, and accuracy. Let's talk about scalability. So I really enjoy and love about the one slide of Prof. Sabah about he got 15 terabyte of data sets.
Yeah.
So it's so wonderful kind of things. I really did kind of fall down just now. So, oh my God, it's really huge. So currently I collected my own. I created Python code and sprawl into the bin. So if Prof. Eden, the trick of Python can pull all the images in one shot of 7-line code. So currently I have 10,000 to 20,000 each of Bau and so on. But I really kept for my research right now, not publicly shared yet. Okay. So obviously accuracy is minimized. Just now we talked about Dr. Faiz and me classifying the fish, kind of minimizing the Q error, hopefully. So yes, this is the most important thing that for all researchers in here should use AI in many things. So currently, if you guys take a look at here, so I just happen to do research in here, not yet automate and prediction. So the one that we did right now is the planning and production and quality control. So we talk about image recognition, color, and so on, because related to Bao in Kedi catfish, we have several colors and so on. So that is the small pieces of branches from this huge perspective of research. So many things can be done by AI. Okay, what are the strategies that we face? Basically, I list this down as 5 things. So first is data collection. Obviously, by seeing the one that the Key University have, 15 tera, is a wonderful and beautiful scenery of research compared to us right now. So basically, what is the data means for AI? The more you have the data, so yeah, the reliable and more intelligent the system you will have. So that would be how to say, supplement for Prof talk just now. The Prof got sonar, and the location of camera at the UAV or UFO, the Prof mentioned earlier, is very nice. And I like that two cameras on board. Okay, so basically, regards to the images, so we have, I think, more or less the first speaker mentioned about the turbidity, suspended particles, value of light, and so on. So I will talk about that. So that will be the struggle within of this particular research perspective. So now we are having 5 categories. I think we just started 2 years back ago to collect all the fishes data. So we have on the ground fish, and recently we collecting underground fishes images in Malaysia for Malaysia species fish species. So that's what we are doing right now. So happen to be thousands still, not too much. Right. The second is AI model classification, whatnot. So obviously everyone in the floor knows about machine learning and deep learning, I guess. So the reason why we jumped into the deep learning, basically, this handle the variation of fish, as I mentioned earlier, Kili, Baung, and Haruan could be without the knee side, and so on. So that is basically looks similar in physical, but the God created them differently. So that would be happen to be nice thing in Malaysian society. Okay, right. So the model, the one that we need to try harder now is model and training optimization. So basically, this is simple. We split them into 80-20 perspective. And currently, what we are doing is basically transfer learning, the things that we brought into what has been stable and well known in society. So basically, the resonant, efficient, and obviously now we are currently fine tuning and prepare our our own fish net. It's not fish net, but fish net, artificial intelligence network. Yeah. So we are trying to do for the Malaysian perspective of fishes. Obviously, hyperparameter, if I may use this term. So basically, this will be, I think, very general to everyone, those who are doing research in AI. So this is in terms of academician parameter things one. So real time. So this now we happen to struggle. So saying that we have already saw in the Prof Sabah videos just now. So we have underwater. So yeah, the struggle we did is the camera and the UFO and UAV. They mentioned that by the first speaker just now. So currently we are the one that we try to approach Prof Sabah is basically to have an intelligent and academia partners to start with the Peninsula Malaysia and including Borneo side of Malaysia to study the underwater fishes datasets and whatnot underwater. So yeah, now currently what we are doing is we're just having a small coverage of grants. So we can afford to have a Jetson Nano and Raspberry Pi, for instead of Arduino, it's for sure we have. But we just try to stimulate in small scale, including the lab. Okay, so this is the major things that need to be faced by us. Obviously mentioned also turbidity, reflection, and refractions, spectral distortion mentioned by Prof. So we do have planned all of these 4. So basically we still doing at the underground work, not publish anything yet, because we still don't have a good part of hardware specific to be published in journal. So that's what we want to see first, and we want to have a good hardware, and we try to push the limit. Right, so this is pre-processing and things. I think that will be thing. Okay, so a bit of what we have doing right now. So I will be sharing you the 3 stages that we have. 2019-20, I went to fish pond in Segamat, the southern states of Peninsular Malaysia. So we started AI-powered classification model. We call them Aqua AI. Okay, so this is me, the only me in 2 from the right. So went to Segamat with This is College Community Sekamat 2, Encik Khairuddin, currently doing PhD. And me, this is the owner of Aminah Rahman Agro Farm. We went there, and what we tried to find is basically many things. So we went there, we have the letter of intent, we have the collaboration with her company. So basically we try to see and look how the demand is, and after this we try to make it bigger size. So I already 2 or 3 times went there to visit, because this place a bit far from here. I think nearly 2 hours driving. So we kind of need to feel that jungle. So the environment was very fantastic, very nature, and the sound of river is very nice and so on. Okay. Reserve forest. Near to the reserve forest in Malaysia. Stated by the government. So the government gave to her as a collaboration for 5 years and see what happened, and the government will extend the license. So So this is the one that we started to make world see what we have. So this is the one that we have for our page. So basically, I think this will be the same. Okay, this is the one that we have now. We implemented and published our technology by through my website, NMZH Education. Later on, I'll share to you the link. So this is the way that we do. So basically, we collect all the images and we try to demonstrate our technology through our website. So through the website, we have many perspective and application of AI for the public. So not only underwater, we have biomedical, we have this is wound classification, collaboration with hospital for diabetic kind of thing. So we have several collaborations out there. So this is the way that we uploaded the files and try to this, and basically this is how one in one of those particular things. So based on that, as I mentioned earlier, we collected the data by our own, but still not published yet. So this is the achievement so far. We have bronze and silver in 2 competitions. So this is 2019 and 2020, and this is 2024. So this is a basic idea. So the moment that we bring in any kind of features which has been classified by us, so the idea of classifying them is there. So this is the one. I think this is kind of demo from us. Okay, so this is NMZH Education. You can straightforward go to the link and just this is for example prediction. It's a real time. It's nothing hidden. So we have front end and back end over here. So the front end is web based, and the back end is the cloud processing AI API. So we have at the back. Secondly, we enter kind of environmental parameter integration. So stability based on soil relative relation. So what we have is Zenith environment analytic for soil monitoring. So we have this. We collected the data. Yellow that try to say that if we have this particular perspective related to the underwater water classification task. So that we started 2 things: underwater and stability. So this is the one that we have. We won't go on that. And last but not least, this we will doing in 2021, coming soon in quarter 3 in 2005 for real-time underwater imaging system. So basically, currently we are doing things because the limitation of student over here. So I need to do by my own. Yes, because this is not the student project, but this is my project. Okay, so the perspective that we can see right now is obviously big. We have marine conversion. So currently, we are negotiating with Polytechnic Kuala Terengganu or MUMT. We want to try to work with the Marine Research Collaboration University in Malaysia, UMT they call it. So the university which really deep in ocean and water technology is located in Terengganu. So we still in communicating to get some collaboration with them. Fisheries management, I mentioned, Aqua AI, tourist education is one of those. So those are familiar. I think this would be nice thing to go as UAV and other things. Okay, but the challenges is this. Obviously, data, as I mentioned again and again. So without the data, we can step forward. We cannot step forward. So this is, we don't know how we need to have a good collaborator and reciprocal and win-win situation. So competition cost, obviously, we don't have a big machine right now. We are struggling to have grants from the government. So once we have, we will set it up for the GPU locally. And currently, we are subscribing the upstairs cloud computing. It's not happening in here. So yes. So to the end of this, I think the idea of to conclude everything, this is the takeaway notes. So AI is significantly improved the fish classification, so that will be happen, and we have 95 to 92% of accuracy for this particular task. Real-time image processing, support conversion and fishery. So this is the things that we wanted to collaborate with the ISCO companies in Malaysia. And yes, underwater monitoring is our vision for 2 or 3 years time from now. So I think, okay, a bit of our lab. So this is us, me and my students. So basically, we started the journey of AI from 2019, the moment I applied from PhD. So I set it up in 2021 with one goal, 1 bronze, 8 medals, and last year we have 38 medals of various applications of AI, not only underwater. So underwater helped us in 2 products. So this is us. So I think, this is me linking, and we have a YouTube channel for this. So currently we have 139 videos dedicated for research products only. No such video like eating or food or anything, no such thing. That will be research videos. So that will be the thing. So I think feel free to ask. Jangan ragu untuk bertanya. La tataradi fi taradik soal. Okay, thank you so much.
All right, thank you, Dorothy, for the discussion, the quite detailed discussion, right? To discuss, and also we're gonna have another session with Professor from German. So, right, we continue the session with the Q&A. So we have 2 questions from the audience. The first one towards Dr. Nick Azarifi. For embedded model to approach using different model for different biomes or location is feasible, or it must composes all, or maybe based on location they are model switching.
Okay, right. So for the first question, basically, I think is about the model, localization model. So currently, we are not having any problem with this because the dataset that we collected right now is widely separated from Perlis to Sabah for all the Malaysian perspective. It's not really tend to be for Muar River, for Malacca River and Kelantan River. So I think you may try by your own by pushing to the link and education rf.gd. So you can try any of the fishes which we mentioned by me just now can be classified clearly. I think more or less 95 as mentioned at the 85 to 92%.
All right, thank you. All right, and then second question: how many fishes classification limit the model?
Currently, we are focusing on the tropical fishes, which are available in Malaysia. So we have, we have baul, harwan, keli, patin, and tilapia. So currently, we are moving forward to many kinds of fishes. including ikan banaraya and so on. So, but that would be our still not published yet work have been done at the back. So still not published yet. There are many. So currently we have got 5.
All right.
Because limitation of the agri farm on in Segamat just now.
All right. Thank you, Dr. Nick, for the information. Dr. Nick is focused on the tropical fish, and then because this is bring higher value from the fish.
So you can go to the NMCH education rf.gd, then straightforward you can try it by real time.
Okay.
This one. So this is my website. So
all right,
it can browse anywhere in the planet.
All right. So the audience, you may refer to the NMCH website for the further clarification and explanation. All right. Last question: how does environmental variability, for example, the water clarity, lighting condition, impact the accuracy of AI-based this classification models?
Yes, for sure. Thank you, Prof. The idea of water clarity, I think turbidity is and light very impactful. So that's the reason why to make things clear, the complementary of optical and visual camera will be good enough to join with the sonar imaging. So that would be a very nice thing to have, since the limitation of camera RGB is very struggling to capture the turbidity in real world.
All right. Thank you, Dr. Nick.